Okay, people who are at a distance today, we've got a pretty short little video here for you that's going to kind of explain some of the big ideas we want to get across. And if you could, I'd ask you to pull out your graphing that you did from the other day for the A cohort. You did some planet graphing on Tuesday where you researched and got some data related to the planets. If you are the B cohort, you did this on Thursday after the test. And I would ask that you pull that out and kind of refer to it as I look at the next couple pages here. So pause the video and pull that out so we can kind of move on from here. And then once you have it, restart and we'll start talking. So when you guys did these planet graphs, you first plotted the density of these planets. And in doing so, you found kind of something interesting, kind of a pattern emerged, is that you had some densities here, and so the inner planets were like this, and then the outer planets, the outer four, I should say, ended up being kind of in this ballpark here. So there ended up being kind of two camps of planets, these inner planets and these outer planets. And when you started looking at things like the revolution, you'll notice that that started low down here based upon the planets, and then started going up like that. So again, there's a big difference between the outer planets and the inner planets. And that's a theme that I want to build upon a little bit, but it has to do with the fact that, remember when we did our graphic novel with the solar system, is that when our solar system formed, it happened in a certain sequence, and when the solar wind was generated, when the sun began to fuse, it pushed out a lot of material from the inner solar system out to the outer parts of the solar system. That explains a lot of the differences between these objects. So I want to explain that a little bit here. So we can kind of see that there is a divide between our inner planets of Mercury, Venus, Earth, and Mars, and our outer planets of Jupiter, Saturn, Uranus, and Neptune. Okay? So what I want you guys to do is I want you to make a T-chart. In this T-chart, I want you to divide into two columns, inner planets and outer planets, and we're going to look at the characteristics of each. And once you've done so, the inner planets are usually going to be made of rock and metal. And the outer planets, Jupiter and Saturn, are mostly made of gas, and Uranus and Neptune are made of ice. So there's a difference there. Okay, like for instance, Earth has a lot of rock at its surface, but it's got a metal core, and the outer planets are majority gas and ice. So there's a dividing line between them. We're going to see lots of differences between these. Inner planets, obviously, if we look at an image here, much significantly smaller than the outer planets. The outer planets are large. Again, huge dividing line. The inner planets have no or few moons. For instance, Mercury has no moons. Venus has no moons. Earth has one moon, and Mars has a couple lumpy baked potatoes that they call moons. They're really small and lopsided and not that great, and eventually they're going to collapse right back down into Mars again and be destroyed in about 50 million years. Whereas the outer planets have many moons. In fact, Saturn, I think, has 72 moons at current count. The inner planets, it might not seem so, but they have a relatively slow rotation. Earth and Mars are about 24, 25 hours. The outer planets have very fast rotations. Jupiter is in about 10 hours. You might think since they're so big they shouldn't be able to rotate so fast, but nevertheless they do. They're kind of like ice skaters who are pulling their arms inward, and they're going to spin faster and faster, and because they have so much more mass, they spin rather rapidly. Now, what's really unique is among the inner planets, Mercury and Venus, their rotation is on the order of many, many months of rotation in terms of Earth time. So they're very, very slow. They're barely rotating at all. The inner planets have a short revolution time. Their time to go around the sun is relatively short, whereas the outer planets can be over a century, depending upon how long it takes to go around the sun. Very long revolution time. The inner planets have no rings about them, and the outer planets, even though Saturn is kind of the main one that has rings, Uranus has pretty visible rings as well, and Jupiter and Neptune have fainter rings, but they have rings nevertheless. And as we indicated with an earlier thing that we did, the inner planets are closely spaced and the outer planets are going to be relatively widely spaced. So we illustrated that in our video, or in our demonstration earlier this week and last week. So these are characteristics I want you to know between the inner planets and the outer planets. Make sure those are in your notes because that's going to be a test question. Now, moving ahead from here, let's go up and let's get rid of that and let's move forward a page. So what you have for your assignment today is a document. You're going to do kind of what's called a technical reading assignment, and you're going to get an overview of each of the planets of our solar system. And what I'm trying to have you do is technical reading. You're trying to get out dry nonfiction material out of the text and be able to answer questions related to it. Make sure you complete this by next class and submit it to me, and I will reward you as you deserve to be rewarded for those efforts. Okay? That's what you have to tackle today. Make sure you use your time wisely, otherwise you will be counted absent. Okay? So thank you for your efforts. Enjoy your weekend.